Welcome back, Deep Divers. Today we're going to be Cracking Open Lifespan by David Sinclair.
It's a fascinating look at aging. Really makes you think differently about getting older.
Yeah, I mean, we all just sort of accept it, right? Like, oh, well, I'm getting wrinkles, I'm slowing down, that's just how it is.
Right, exactly. But Sinclair, he kind of flips the script. Like, he straight up calls aging a disease.
The disease.
Yeah.
Seriously.
Yeah, and not just any disease. He says it's the most common disease, actually. And he argues we should be fighting it.
I mean, I get wanting to stay healthy longer, but calling it a disease, it's like, I don't know.
Well, he makes a pretty compelling case. He actually starts the book by talking about his mom's death.
Oh, wow.
Yeah, it's pretty personal, but it really brings home the point that aging, it has real consequences.
Wow.
And it makes you, you think about your own mortality and all that.
I can see how that would definitely grab your attention.
Yeah, it sets the stage for his whole argument. And then he takes us way back, like billions of years back.
Okay, now I'm intrigued. Where are we going?
To the beginning, or at least, pretty close to it. He talks about this tiny little organism, M. superstes. Ever heard of it?
Superstes. Rings a bell.
Yeah.
Vaguely. Maybe from, like, high school biology or something.
Well, get this. This little guy, it survived a massive drought, like a drought that wiped out almost everything else on Earth.
So it was like a super survivor.
Exactly. And Sinclair, he argues that that understanding how this thing survived could give us clues about how we age.
Okay, so how did it do it? What's the secret?
Well, it basically went into survival mode.
Yeah.
Like, it had this special gene that would kick in under stress and repair its DNA, and it would put reproduction on hold until things got better.
Smart move.
Mm-hmm.
Focus on staying alive first, babies later.
Right, and Sinclair's point is that that we might have inherited that same kind of ancient survival circuit.
So, like, deep down, we have this ability to go into survival mode, too.
Yeah, potentially. And it might be the key to understanding how we age and how we can maybe slow it down.
This is really cool. But so, like, traditionally, haven't we thought of aging as just wear and tear on our bodies? Like, our DNA gets damaged over time, sort of like scratches on an old DVD.
Yeah, that's been the prevailing theory for a while. But Sinclair, he's got a different idea. He says the real issue isn't the damaged DNA itself. It's more like losing the information about how our genes should be working. Like, imagine a DVD player that can't read the disc anymore.
Oh, okay, I see. So it's not just the hardware. It's like the software is glitching out.
Exactly. And that loss of information, that's what leads to all the things we associate with getting older. Wrinkles, weaker immune system, all that stuff.
That's pretty fascinating. So if we could figure out how to stop that information loss or even, like, reverse it, could we actually, like, turn back the clock?
That's the million-dollar question, right? And that's where these things called sirtuins come in. They're like, they're genes that play a huge role in how our survival circuit works. They're involved in all sorts of things like a DNA repair and metabolism.
Sirtuins.
Yeah.
Sirtuins. Okay, so what are they exactly? Can you, like, break it down for me?
Sure. So think of them as these little repair crews that keep your cells running smoothly. They help to keep your DNA in good shape and then make sure your cells are doing what they're supposed to be doing.
Okay, so when these repair crews start slacking off, that's when things start to go downhill.
Pretty much. And Sinclair argues that that as we age, the activity of these sirtuins, it decreases, and that leads to this loss of control over our genes, and eventually our cells and tissues start to break down.
Wow. So these tiny little genes, they're like super important for how long we live.
It seems that way, yeah.
That's incredible. And, he also talks about all this genetic dark matter, like parts of our DNA that we used to think were just junk, but now we're realizing they might actually do something.
Yeah, it's like we're only just starting to understand the whole instruction manual for how to build a human being.
It's mind-blowing. But I'm curious, how did Sinclair, like, get involved in all this? Like, what led him down this path?
Well, he actually made some pretty big contributions early on. He was studying this rare genetic condition called Werner syndrome. Basically makes people age really fast.
Oh, wow. Like Benjamin Button in reverse.
Kind of, yeah. And his research on Werner syndrome really got him thinking about the idea that that aging is a process we could potentially manipulate.
I see. So it's not just some, like, pre-programmed thing we have no control over.
Right. And then he started doing research on sirtuins, but in yeast. And he found that that restricting their calories actually activated these sirtuin genes and made them live longer.
Wait, so like not eating as much made them live longer?
Yep, it was a huge breakthrough, and it really sparked this whole field of research into calorie restriction and longevity.
That's amazing. But I'm guessing he didn't just stop with yeast, right?
Oh no, not at all. He went on to show that sirtuins were important in more complex organisms too, like mice. He even developed this really cool mouse model where they could induce DNA damage and see how the sirtuins responded.
What happened?
The mice actually showed signs of rejuvenation, like even when they were old.
Whoa, that's wild. It's like something out of a sci-fi movie.
Yeah.
It's really inspiring to see how much progress we've made in understanding aging.
It is, yeah. And Sinclair, he's quick to point out that it's not just him. There are brilliant scientists all over the world working on this stuff.
It really is a global effort, isn't it? It's like this collective quest to unlock the secrets of longevity.
Exactly. And there was this big meeting back in 2010 where a bunch of these leading scientists all got together to talk about the new science of aging.
Oh, yeah, I think I read about that. It sounds like it was a pretty important moment.
It was. They presented all this evidence that we can actually influence aging, maybe even reverse it.
And that's got to have some pretty major implications for healthcare, right?
Huge implications. I mean, think about it. Aging itself is rarely listed as a direct cause of death on a death certificate, even though it's the underlying factor for so many diseases.
Yeah, that's true. We treat the symptoms, but not the root cause.
Exactly. And Sinclair, he's like, we need to change that. We need to start thinking of aging as something we can treat.
Okay, but what about all the ethical and societal questions that come with extending lifespan? I mean, what about overpopulation?
Well, Sinclair addresses that head on. He says overpopulation isn't just about how many people there are. It's more about how much we consume, our lifestyles.
So it's not about preventing people from living longer. It's about living more sustainably.
Right. And he also talks about the need to address wealth inequality, making sure everyone has access to whatever longevity interventions we come up with.
Yeah, we don't want a world where only rich people get to live longer, that's for sure.
Absolutely. But now let's talk about what we can do right now today to maybe slow down aging. Sinclair talks about this concept called hormesis. It's basically the idea that exposing yourself to mild stress can actually be good for you.
Wait, stress? Isn't stress the enemy?
It can be, yeah. But in small doses, stress can actually make your body stronger. Think about exercise. You're basically stressing your muscles, but that makes them grow stronger, right?
Okay, yeah, I get that. So what kinds of things are we talking about?
Well, calorie restriction is a big one. And exercise, obviously. And even exposure to cold temperatures.
Like taking cold showers.
Exactly. It sounds crazy, but there's actually some evidence that it can activate those longevity genes we were talking about earlier.
Interesting. I might have to try that. But what about supplements and stuff? Is there anything we can take?
Sinclair talks a lot about NAD. It's this molecule that's it's really important for how our cells function, but it declines as we age.
And we can boost our NAD levels.
Yep, there are supplements for that. And Sinclair even talks about his own dad who started taking NAD boosters and saw a huge improvement in his health and energy levels.
Wow, that's pretty compelling. There's so much to unpack here. It's amazing.
I know, right? And we've only just scratched the surface. There's a whole world of potential therapies and technologies on the horizon, but we'll save that for next time.
Welcome back. So last time we were talking about all this amazing stuff about aging and how we might be able to actually slow it down.
And Sinclair, he doesn't just leave it at theory, he actually gives some practical advice on things we can do, right now.
Yeah, that's what I loved about this book. Is okay, enough with the science. Give me the actionable stuff.
Right. And he starts with calorie restriction. It's got a ton of research backing it up and all sorts of different species.
Like those roundworms, right? The ones that lived, what was it, twice as long?
Exactly. Cynthia Kenyon's work. Yeah. That was a major turning point. It showed that a single gene mutation could have this huge impact on lifespan.
And then everyone started looking for those same longevity genes in, more complex creatures.
Yeah, like us. But, calorie restriction, it's not exactly everyone's cup of tea.
No kidding. I love to eat way too much.
Me too. But luckily, Sinclair offers some other options like intermittent fasting or those fasting mimicking diets. Have you heard of those?
Yeah. It's you eat very specific things for A few days a month, right?
Something like that, yeah.
Yeah.
And the cool thing is there's this study where people saw improvements in their health markers after just 3 months. Like their blood pressure went down and their inflammation markers improved.
That's pretty impressive. 3 months isn't that long.
Nope. It gives you like a little bit of hope,
Uh,
that you can actually make a difference.
Definitely. But Sinclair also acknowledges that, like, calorie restriction, it's not a one-size-fits-all thing.
Right, right. He talks about these centenarians, people who live to be over 100, and some of them, they didn't live these super healthy lifestyles. They smoked, they ate whatever they wanted.
And they still live forever. Sounds like my kind of people.
I know, right? It's fascinating. He talks about Nir Barzilai's research where they studied these centenarians, and it seems like some people might just have these genetic variations that like put them in a constant state of low-level stress.
So they're, like, always in survival mode, even if they're eating cake and smoking cigarettes.
Kind of, yeah. It's like they've got this built-in longevity advantage.
Lucky them. But for the rest of us mere mortals, what can we do?
Well, exercise is a big one. Like even moderate exercise can really make a difference in terms of activating those longevity genes.
So we don't have to, like, run marathons or anything.
Nope. Sinclair says even like brisk walking a few times a week can have a huge impact. There are these studies where they looked at runners, and they found that even people who only ran like less than 15 minutes a day, they had a much lower risk of heart attacks and overall mortality.
That's good to know. I could definitely handle a 15-minute walk.
Yeah.
But can I just outrun a bad diet? Like, if I exercise enough, can I still eat all the pizza I want?
Uh-huh. I wish. Unfortunately, no. Sinclair says exercise works best when you combine it with healthy eating. Like, they complement each other.
Okay, fine. Pizza in moderation. But speaking of activating those longevity genes, he also talks about temperature. Right?
Yes. It goes back to that whole Amuso superstes thing. Remember how it survived that extreme drought?
Yeah. Survival mode.
Exactly. So Sinclair says that exposing ourselves to cold temperatures can kind of trigger that same survival response in our bodies. He actually, he kind of jokingly regrets that he didn't embrace the cold more in his own life.
So, like, cold showers are back on the table?
Maybe. He even mentions saunas, believe it or not. He talks about this research on yeast, where they found that heat exposure actually made them live longer.
Really? Saunas? Huh, who knew?
It's pretty wild, and it makes you wonder, like, what's the connection there? Is there something about heat stress that can trigger longevity pathways in humans too?
That's definitely something to think about next time I'm sweating it out in the sauna.
Yeah.
But so far we've been talking mostly about lifestyle changes. What about, like, actual medicine? Is there anything on the horizon that could help us live longer?
Oh yeah, tons. This is where things get really exciting. Sinclair talks about all sorts of cutting-edge therapies and potential drugs. One of the most promising is metformin. Have you heard of that?
Vaguely. Isn't it like a diabetes drug?
Yeah, it is. But it seems like it might have some anti-aging properties too. It basically activates this thing called AMPK, which is like this cellular energy sensor that's really important for metabolism.
Okay, so how does that tie into aging?
Well, as we age, our cells become less efficient at using energy, and metformin seems to help them get back on track. Sinclair actually talks about his own father who started taking metformin, and he saw some pretty amazing results.
Like what?
He had more energy, his blood sugar levels improved, and he just felt a lot better overall.
Wow, that's pretty cool.
Yeah.
But it's just one anecdote, right?
Right, exactly. But there's this big clinical trial going on right now, the TAMA trial, and they're specifically looking at whether metformin can actually slow down aging and delay the onset of age-related diseases.
And if it works, like, what happens then?
Well, it could be huge. Like, it could potentially lead to the FDA actually recognizing aging as a treatable condition.
Wow. That would be a major shift in how we think about aging. And it would open up a whole new world of possibilities for treating it.
Exactly. But metformin is just one piece of the puzzle. Sinclair also talks about NAD boosters, which we touched on earlier.
Yeah, the supplements that his dad was taking, what's the deal with those?
So NAD, it stands for nicotinamide adenine dinucleotide. It's a mouthful, I know. But basically, it's this molecule that's essential for a lot of cellular processes. Like, it's involved in DNA repair, energy production, all sorts of things.
Okay, but what does that have to do with aging?
Well, as we get older, our NAD levels decline. And that's thought to be one of the reasons why our cells start to malfunction and we experience age-related decline.
So if we can boost our NAD levels, could we reverse some of that?
Potentially. That's the idea behind NAD boosters. And there's some pretty interesting research both in animals and in humans. Like in mice, NAD boosters have been shown to improve mitochondrial function, reduce inflammation, even reverse some cognitive decline.
Wow, that's pretty impressive. What about in humans?
Well, the research is still in the early stages, but there are these anecdotal reports of women who took NAD boosters and actually started menstruating again, like even after they had gone through menopause.
Whoa, seriously. That's crazy.
It is. It makes you wonder, like, what else could NAD boosters do? Could they, like, extend fertility? Could they reverse other age-related changes?
I'm definitely intrigued. But let's move on to another type of therapy he mentioned, senolytics.
Oh, yeah, those are fascinating. So remember those senescent cells we talked about earlier? The zombie
Ones
cells?
that accumulate as we age and cause all sorts of trouble.
Exactly. Well, senolytics are drugs that specifically target those cells and kill them off.
So it's like clearing out the cellular trash.
Pretty much. And it seems like it could be a really promising way to rejuvenate tissues and organs. There's even some research suggesting that sirtuins might actually play a role in regulating cellular senescence.
So it all ties back together.
It does. It's all connected. But now, get ready for this. We're about to go deep into the sci-fi realm. Sinclair talks about reprogramming genes to reverse aging.
Reprogramming genes,
Yeah.
like literally turning back the clock.
That's the idea. So these reprogramming genes, they were originally discovered in stem cell research. And it turns out if you use them in certain ways, you can actually reset the aging clock in cells.
And they've done this in animals.
Yep. They did these experiments in mice, and it was incredible. Like, they took old mice and reprogrammed their cells, and the mice actually started to look and act younger. They even regrew some of their fur.
That's mind-blowing. So does that mean we could one day like take a pill and reverse our aging?
It's possible, but there's still a lot of research to be done. Like, reprogramming genes can be tricky because it can sometimes lead to uncontrolled cell growth. So scientists are working on figuring out how to do it safely and effectively.
Okay, yeah, safety first. But it's definitely exciting to think about the possibilities. And he also mentions gene editing, right? Like using CRISPR to target the underlying causes of aging.
Yes, CRISPR is amazing. It's basically this molecular tool that allows scientists to edit genes with incredible precision. So they could potentially use it to like repair age-related damage in our DNA.
Wow. It's like we're rewriting the code of life. But is there a lot of like ethical debate around gene editing?
Yeah, for sure. Especially when it comes to editing germline cells, which are the cells that pass on genetic information to our offspring. Like, if we edit those cells, we're essentially making changes that could be passed down to future generations.
And that's a whole can of worms, right?
Right. So Sinclair talks about the need to proceed with caution and to have open discussions about the ethical implications of these technologies. But now let's switch gears a bit and talk about biotracking and personalized medicine.
Okay, yeah. He gets into that stuff too, right? It's like the future of healthcare.
Exactly. So biotracking is basically using sensors and AI to monitor our health in real time. Like, imagine wearing a smartwatch that can tell you your blood sugar levels, your hormone levels, all sorts of things.
That would be amazing. No more like going to the doctor for blood tests.
Right. And this constant stream of data, it could help us to catch problems early on and potentially prevent them from getting worse.
But what about privacy? I mean, who has access to all that data?
That's a valid concern. And Sinclair talks about the need for strong privacy protections. He envisions a future where we have control over our own data and can choose who we share it with.
Okay, that makes sense. And what about personalized medicine? How does that fit in?
So personalized medicine is basically tailoring treatments to our individual genetic and epigenetic makeup. Like, instead of giving everyone the same drug for, say, high blood pressure, doctors could use genetic testing to figure out which drug would work best for each person.
That's so cool. It's like medicine made just for you.
Exactly. And Sinclair gives this example of pharmacogenetics, which is using genetic testing to predict how people will respond to different medications.
And he even talks about his own mother, right? How she had a bad reaction to a drug that could have been avoided if they had done genetic testing.
Yeah, it's a really powerful example of how personalized medicine could potentially prevent a lot of suffering.
It's incredible. It feels like we're on the cusp of a whole new era of medicine.
We are. It's a really exciting time to be alive. But with all these new possibilities come new challenges, you know. We have to think carefully about the ethical implications of these technologies and make sure we're using them responsibly.
That's a great point. It's not just about living longer, it's about living better and making sure everyone benefits from these advances.
And we're back. It's the final stretch of our lifespan deep dive.
Yeah.
We've gone through the science, the potential therapies, and now we got to face the music. Like, what happens if we actually do figure out how to live a lot longer? What happens to society?
Sinclair tackles those questions head on. He doesn't shy away from the big, kind of scary stuff, like overpopulation. That's the one everyone jumps to. Too many people, not enough resources.
Right, exactly. But Sinclair, he pushes back on that a little bit. He says it's not just about, how many people there are. It's about consumption, our lifestyles, how much we use, how much we waste.
So it's not like, oh no, people are living too long. It's more like we need to figure out how to live sustainably no matter how long we live.
Yeah, pretty much. He uses Australia as an example, actually. They've got like a really low population density, but they're still worried about overpopulation.
Interesting. So it's more about like perception than reality.
It seems like it, yeah.
Yeah.
And he also talks about London in the 19th century. They had this huge population boom, and it led to all sorts of problems, like terrible living conditions, disease outbreaks.
Oh, yeah. Wasn't that when cholera was running rampant?
Yep. And he tells this really interesting story about John Snow, this doctor who figured out that cholera was spreading through contaminated water.
Oh, yeah. I remember learning about that. Like, everyone thought it was spread through the air, but he, mapped out all the cases and traced it back to this one water pump.
Exactly. It's a great example of, how science and public health can help us deal with the challenges of a growing population. And, it's interesting because as life expectancy has increased in a lot of developed countries, birth rates have actually gone down.
Oh, yeah, that's true. So maybe the overpopulation thing, it's not as big of a deal as we think.
Maybe not. But there are other things to worry about, like wealth inequality.
Oh, yeah, that's a big one.
Yeah.
If rich people can afford to live longer, the gap between the haves and have-nots is just going to get bigger.
Exactly. And Sinclair, he really emphasizes that point. We need to make sure that any longevity interventions we develop are available to everyone, not just the wealthy elite.
Yeah, totally. We don't want to create a world where only the rich get to live forever. But what about, the way we structure society? Like retirement, healthcare, all that stuff.
Yeah, that's another big issue. Our current systems, they're just not designed for a world where people live to be 120 or 150.
Right. Are we going to be working till we're 100? Will we even want to retire?
Good questions. And Sinclair, he doesn't have all the answers, obviously, but he says we need to start thinking about these things now and figuring out how to adapt. Maybe we need to rethink the whole concept of retirement, or maybe we need to create more flexible work arrangements so people can, work longer if they want to, but also have time for other things.
Yeah, it's like our whole concept of a lifespan would have to change.
Exactly.
Yeah.
And then there are the really tough questions like, what about death? If we can potentially live much longer, how do we deal with the inevitability of death? When do we decide it's time to go?
Yeah, that's heavy stuff. I mean, right now we kind of just accept that, most people live to be 70, 80, maybe 90. But if that changes, if it becomes normal to live to be 150, 200, does that change our relationship with death?
It might. And Sinclair talks about the importance of having open and honest conversations about these things. As individuals and as a society, we need to decide what we value and how we want to approach these big existential questions.
That's a great point. It's not just about science. It's about philosophy, ethics, all of it.
Exactly. But ultimately, Sinclair, he's optimistic, He believes we can create a better future, a future where longer lifespans lead to greater happiness and fulfillment, not just more years.
Yeah, I like that. It's not just about quantity, it's about quality.
Right. And he ends the book with this call to action. He says we all need to get involved, stay informed about the science of aging, and participate in these important conversations.
So it's not just up to the scientists, it's up to all of us to shape the future we want.
Exactly. It's a really empowering message, I think.
So that brings us to the end of our lifespan deep dive.
It's been quite a journey, hasn't it?
It has. So much to think about, so much to ponder. But before we go, let's do our little recap just to bring it all together. Ready?
Yeah, I mean that.
Okay, so first takeaway. Aging is not inevitable. Sinclair says we should be treating it like a disease, something we can fight.
Number 2, our bodies have this ancient survival circuit passed down from the dawn of time, and we can activate it through things like calorie restriction, exercise, and cold exposure.
3, Sirtuins, those awesome little genes, they're the key players in regulating that survival circuit.
4. NAD, that super important molecule, it declines as we age, but we can boost it back up with supplements and maybe even reverse some age-related decline.
5. Metformin, that diabetes drug, it's showing some serious potential as a longevity medicine, and there's that big trial going on right now to see just how effective it might be.
6. Senolytics, those are the drugs that target those pesky zombie cells, the ones that cause all that inflammation and tissue damage. Get rid of those, and we might be able to rejuvenate our bodies. 7. Reprogramming genes, that's like the holy grail.
Yeah.
Literally resetting the aging clock at the cellular level. Still a long way to go, but the early research is super promising.
8. Gene editing with CRISPR, it could be a game changer. Imagine like going in and repairing the actual damage in our DNA. Super powerful stuff, but also, ethically complex.
9. Biotracking and personalized medicine. That's all about like monitoring our health in real time and tailoring treatments to our individual needs. The future of healthcare, basically.
And last but not least, number 10. Living longer comes with a whole host of ethical and societal challenges like overpopulation, wealth inequality, even our relationship with death. Big questions, no easy answers.
Wow, we covered a lot.
We did. But it's important stuff, It's about the future of humanity, really.
Totally. And that's what makes it so fascinating. So there you have it, folks. That's our lifespan deep dive. Hope you enjoyed it. Hope you learned something. And hope you'll join us again next time for another mind-bending exploration. Until then, stay curious.